All right, getting into mapping functions and transformations. So going to look at a few different things in this lesson here. First, we start off with a review of functions. Now, functions from Algebra 1 are going to be related to what we do with transformations in geometry, and I want you to try and see that connection here. So a correspondence between, like it says in your paper here, a correspondence between two sets A and B is a function of A to B if and only if each member of A corresponds to one and only one member of B. So you may or may not remember this from last year, but it's very, very important that we do review it. So what is a function? We're going to help, instead of reading this word for word, we're going to use the diagrams to kind of help us, okay? So there are 4 examples here of, and 3 of them are functions and 1 of them is not a function. The reason why, see how it says this is a function here, this is a function, this is a function, and this is a function. These 3 are functions because everything in set A corresponds to only one thing in set B. But if you look at this one right here and how this one is different from the other 3, see how in set A the A corresponds to D and it also corresponds to G? That is not allowed in a function. So everything in set A can correspond to only one thing in set B. Now, if you look at the first one's the easy one because obviously everything's 1 to 1 here. Okay, so that's obviously a function. The second one's a little confusing because wait a minute, the F here, the B goes to F and so does the C. But that doesn't matter for a function. It's okay. The set B can be repeated, set A cannot be repeated. All right, so that is a function. Same thing here, A and C both go to G. That's very similar to this one here. So those are functions. This is not a function because A goes to D and A also goes to G. So that's from function. You should have learned that in Algebra 1. All this is review. All right. Now, just some practice with that. All right, so looking at this one here, and I want you to try these based on what we just talked about. Pause the video and try these. All right, see if you can, you don't have to circle it, but just put F or not F, next to it or something, just to kind of test yourself out here. All right, I'm gonna have you pause and come back. All right, so hopefully you tried these. Now the first one, the 2 goes to 7, the 0 goes to 7, and the 5 goes to 3. Nothing in the domain was repeated, therefore this is a function. It doesn't matter that they both went to 7. That's okay. The range can be repeated, the domain cannot. All right, so this is like set A, this is set B. Set A, set B. Set A, set B. How about this one? Well, 2 goes to 7 and 2 also goes to 3. That is not allowed, so this is not a function. And then in this one here, 7, 2, and 5 all go to 3. That's okay, as long as you don't have two arrows coming off of 7. You don't have anything. The 7 only goes to one thing, the 2 only goes to one thing, and the 5 only goes to one thing. As long as you don't have this going on, you have a function. So yes, it is a function. That's review. Now, what is a mapping? A mapping is a correspondence between the pre-image and an image. All right, so in transformations, we have a pre-image, we have an image. If and only if each member of the pre-image corresponds to one and only one member of the image. So basically, if we have a function, it's a mapping. Okay, it's similar to functions, except we have with shapes now, say triangles or quadrilaterals or whatever. All right, so look, we'll see what I'm talking about here. See this example right here? This is a mapping, just like the other ones were a function. So it's either a mapping or not a mapping, okay? This is a mapping. Why is it a mapping? Because K maps to N, L maps to O, and M maps to P. Got it? Here, this is a mapping because M can map to R, right? K can map to Q, and L, what's L going to map to? Well, it doesn't matter. We'll map to Q or R, right? So let's just say it maps to Q again. That's okay. It doesn't matter if you have less ones over here, it's okay. But see, look at this third example right here. Let's try it. So K maps to S. All right. L maps to T. M maps to U. But then nothing mapped to V. So M would also have to map to V. So M goes to U and M also goes to V. That's not possible. It's not possible for M to go to U and also go to V. M's got to go to one thing. It can't go to two things. So you can't have 1 to 2. You can't have one thing going to two things. All right, so that's why it's not a mapping. In this one here, L can go to T, K can go to T, and M can also go to T. That's possible. They all can go to the same exact point, but you just can't have this right here where maybe M went to two different things. That's why it's not a mapping. All right, so I know that's a little confusing, but see if you can use the logic we just talked about there for a mapping and do these three examples. Determine if it is a mapping or not. Pause the video, come back. All right, so let's try this one out right here. So we could say that what? A goes to what? Anything, right? A can go to I, okay. How about F can go to H? It doesn't matter. You can go to G. It doesn't matter. E goes to G, okay. What about D? Okay, D can also go to H. C can go to H. And B can go to I. All right, that's okay. So you have a 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. You have a hexagon here. You have a hexagon, and it's going to a triangle. That's okay. A hexagon can become a triangle. So yes, it is a mapping. Let's try this one. D can go to H. C can go to G. E can go to I. B can go to M. F can go to L. And A can go to K. But what about J? Where did J come from? Well, something else maybe A also goes to J. That's not possible. How can A go to K and also go to J? Once you do a transformation and change the point, it can only go to one place. So each point in the pre-image can only go to one point in the image. So because there's more points in the image, this is not a mapping. And then this one here, 1, 2, 3, 4, you have more points here, or you have the same number of points, right? So B to E, C to F, D to G, A to H. There we go. There's 1 for 1, so that would be a mapping, yes. Okay? You just can't have more points in the image than you do in the pre-image. All right, and then we just talked about not all mappings are useful. We don't want to start with a triangle and end up with a segment or a point after we map them. So what we're going to be studying when we get into our transformations is we're only going to be studying one-to-one transformations. One-to-one, one-to-one. Got it? So if we have 4 points, we want to end up with 4. If we have 3, a triangle, we want to end up with 3. If we have 6, a hexagon, we want to end up with 6. All right? So an example here, this would be what's called a transformation. Why? Because we have 4 points and we still have 4 points. This would not be a transformation. Even though it may be a mapping, it's not a transformation. So this is a mapping, but it's not a transformation. Because 4 points are now going to 3. So that is not a transformation here. All right? So what's a one-to-one function? 1 to 1. See, A goes to D, B goes to E, C goes to F. 1 to 1. Look at this one. This is 2 going to 1. That is a function, but it's not 1 to 1 because B and C both go to F. That's just like what you have here, not being a transformation. So when you have less in set B than you have in set A, it's a function, but it's not a one-to-one function. When you have less points in the image than you do in the pre-image, it's not a transformation. It might be a mapping, but it's not a transformation. trying to make the connection between transformations and one-to-one functions now. Okay? So, answer these here. Is it a transformation or is it not a transformation? So pause the video based on what we just talked about. If it's a one-to-one correspondence, it is a transformation. If it's not one-to-one, then it's not a transformation. So pause the video, see if you can get those, then come back. Okay, so hopefully you saw this down here. A transformation, pre-image to image, must have the exact same number of points. So let's see. 1, 2, 3, 4, 5, 6 points. And here we have 3, so this would not be a transformation. 1, 2, 3, 4, 5, 6 points. 1, 2, 3, 4, 5, 6, 7 points. 6 to 7, not a transformation. And here, 1, 2, 3, 4 to 1, 2, 3, 4, and that would be, yes, a transformation. Okay, so again, no here, and then yes here. All right, so I will see you in class tomorrow to practice what it is, the relationship between a function and transformation, a one-to-one function and a transformation, and determining, is it a mapping, is it a transformation, what is it? All right, so I will see you then.